A and B are integers, A and B are integers, A and B are integers, and B is not equal to 0. And B is not equal to 0, and B is not equal to B0. B is not equal to 0. A and B are integers, A and B are integers, A and B are integers. And B is not equal to 0, and B is not equal to 0. And B is not equal to 0, and B is not equal to 0. In other words, a rational number is a number that can be written as one integer over another. One integer over another, one integer over another, one integer over another. So, bam. Fraction, fraction, fraction. Alright. Be very careful. Remember that a whole number can be written as one integer over another. The integer in the denominator is 1 in that case. For example, 5 can be written as 5 over 1. Hold up. The natural numbers, whole numbers, and integers are all subsets of rational numbers. They'll get more in depth. So basically, this is all. B is all the pieces, all the pieces, all the pieces, and A is how many pieces you have, how many pieces you have, how many pieces you have, how many pieces you have. The whole pie, the whole pie, the whole pie, pieces of the pie, pieces of the pie, pieces of the pie. Okay? And of course, well, never mind. Yeah, real quick, usually this is lower than this because, of course, this is pieces of the pie. This can never be bigger than this. But sometimes it's mixed, and you'll see that, like, way later on. And blah, 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 subsets of rational numbers. So the same thing. Subsets of rational numbers. Rational numbers, big thing, big thing, big thing. You're a part of rational numbers, you're a part of rational numbers, you're a part of rational numbers. Irrational numbers. I equals brace x, straight line x. Wait, x, 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 straight line. X is a real number that is not rational. X is a real number that is not rational. X is a real number that is not rational. In other words, an irrational number is a number that cannot be written as one integer over another. It is a non-repeating, non-terminating decimal. So you can't, writing one over another wouldn't be possible. So let's just say this number would be 17 and this number would be 15. The bigger number can't be on top or something like that. Just think of it like that. In the future you'll be able to find a technique, but for now you can just use that as an analogy. Non-repeating, non-terminating decimal, it'll be easier once we read this. One big example of irrational numbers is roots of numbers that are not perfect roots. For example, the square root of 17 or 5 to the third power. 17 is not a perfect square. So the answer is non-terminating, non-repeating decimal, which cannot be written as one integer over another. Similarly, 5 is not a perfect cube. Its answer is also non-terminating, non-repeating decimal. So 17 is not a perfect square. So square root of like 18 is 999, but 17 can't have a perfect square root. It's an uneven number that can't have a square root. Can't have a square root, can't have a square root, can't have a square root. And 5 to the third power, you can't multiply a number of times itself, times itself, times itself, times itself, times 3 to get 5. You can't multiply a number times itself times 3 to get 5. So this is not perfect square, non-perfect square, non-perfect square. And when a problem can't be solved, you 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 can't be solved. Non-terminating, non-terminating, non-terminating. And non-repeating, I think it'll be answered in pi. Another famous irrational number is pi. Another famous irrational number is pi symbol, pi. Pi symbol, pi symbol, pi symbol, pi, pi, pi. Even though it is more commonly known as 3.14, that is a rounded value for pi. Actually, it is 3.1415927, blah, 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 blah. It goes on forever. It will keep going on and on. Keep going and going and going without any real repetition or pattern. In other words, it will be a non-terminating. It doesn't end, can't be solved. It doesn't end, can't be solved. It doesn't end, can't be solved. Non-repeating, no pattern, no pattern, no pattern decimal, which again cannot be written as a rational number. One integer